Our next presentation is entitled Hang Tight, Using Digital Aids to Mount Māori Pātaka. Allyn is the exhibit preparator and Mountmaker at the Bishop Museum. He started mountmaking at the Bishop Museum in 2019, just before the world shut down for the COVID pandemic. Prior to mountmaking, he finished up his degree in art sculpture while working on custom mount fabrication. When not working on mounts for upcoming exhibits, he might be repairing a gate or a volcano. Allyn?
Aloha mai kako. Good morning, everyone. And thank you to the committee for choosing my presentation. Today's presentation, Hang Tight, Using Digital Aids to Mount the Pātaka Whakairo. Start out with a little bit of background on our museum. Bernice Pauahi Bishop Museum was founded in 1889 by Charles Reed Bishop at the request of his wife, Bernice. The original building, comprised of the Kahili Room, Festival Gallery, now called Long Gallery, and Picture Gallery, was completed in 1890. William T. Brigham was hired 2 years later in 1892 as the museum's first curator and director. He proposed and later completed the Hawaiian Hall edition in 1903. In that time, 3 purchases were made from the Auckland-based collector and dealer Eric Craig. The cultural objects purchased from Eric Craig became the early basis for the museum's Maori, Australian, and Melanesian ethnographic collections. I'm going to read a summary of the curator summary of the current exhibition, ʻUla Wena, Oceanic Red. Just moved way too far in my script. The phrase ʻUla Wena refers to a glowing red, one whose warmth envelops Hawaii each day, first at Kumukahi, the storied easternmost point of the islands. It is the strength of the sun, but also the bounty of reds found in the plants and animals it nourishes. ʻUla Wena is a red experience beyond seeing. This redness is felt in mele, song, mo'olelo, stories, and the Wena, warmth of kinship. Red conveys constellations of ideas densely populated by meaning. Red, beyond color, shade, or hue, elevates the senses, shifts emotions, affirms kinships, enlivens passions, and consecrates the sacred, and sets apart the profane. The object I'll be focusing on today is a Pātaka Whakairo, part of the original purchase from Eric Craig. Again, I'll summarize the curators. In Aotearoa, Pātaka storehouses are functional repositories for basic needs, storing preserved foods and other important items for the community. However, the highly ornamented Pātaka Whakairo were used to protect treasured items of high-ranking chief, symbols of genealogical power and prestige that also reflects on the broader community. The carved panels displayed high on the wall from a Pātaka Whakairo are only mentioned in records as house part, yet representing so much more. The 5 pieces are carved with ancestral figures and covered with kokowai, a red earth pigment, served as the front to a complete Pātaka Whakairo, showing the relative wealth of the chiefs and the community as a testament to the well-being of the people. I started at the museum in the summer of 2019 with experience in art handling and fabrication, but a fresh mind to mount making. While working on my first 2 exhibits and just starting to get a hang of how it all worked, I watched a lot of previous IMF presentations. I was informed that I would be working on a project with around 100 artifacts from around the Pacific. This show would complement the 13th Festival of Pacific Arts and Culture, FESPAC. And oh yeah, in typical tight time fashion, that was going to open in the summer of 2020. One object that was in my mind of particular challenge was the 5 elevated wall-hung panels. They were large and a challenge to view altogether for any extended period of time, especially in a workspace. Not to mention all the other mounts that I was going to have to give my attention to. I tried a few things such as stainless steel brackets and epoxy cast interfaces, but they didn't seem right, and they were going to be a challenge to install and align properly. I took a break to work on other mounts and think about how I would proceed. One day in March, we found that the state was going into an indefinite work from home order. A respiratory virus was spreading rapidly around the world. Great. How do I continue during a global pandemic? With just a few months till the opening of the show, I received a call from my boss. Hang tight, the show's been postponed. Fast forward to 2023, the show is back on with an altered list and a new design, more mounts, but also more time and more experience. I had since started to explore the options of 3D scanning and printing, and this seemed like a possible aid to my situation. I started by scanning the 5 panels one side at a time. I use a Einstar infrared stereoscopic scanner made by Shining 3D. It's relatively affordable and capable of sub-millimeter accuracy. It's by no means the best, and scanning has a steep learning curve and limitations, but does the job. As it scans, it needs to maintain tracking, which can be done using reflective stickers, but that's less of an option with museum artifacts. As an alternative, the software can keep track of its location using textures and shapes. This can be slower, and doesn't work well on large flat surfaces, but luckily these panels had a lot of intricate, deep carvings, and it made the scans relatively easy. Scans took about 30 minutes per panel. After scanning the panels, 2 sides, they needed to be aligned. There's an option to automatically align them, and I think that's how I got to that, so obviously it doesn't always work perfectly. But the other option is manual alignment, and it's easier than you might think. You just have to select 3 matching points on your scans. Hopefully you have enough overlap between your scans that you can do that, and click a button, and it does a pretty good job of bringing it together once you give it some guidance. One of the advantages of this process over direct epoxy casting is the ability to alter dimensions, such as removing undercuts that may otherwise capture an object, or in this case, offset to allow clearance of thicker paddings, such as benchmark polyfelt. To do this, I used a free software called Mesh Mixer, which, evidently, as I found out, is commonly used in the dental world for oral molds. Bringing in the OBJ file from the scanner, I used the Make Solid set it to accurate, made sure that the cell sizes for solid accuracy and mesh density were similar, and set the offset distance to the 16th of an inch that I measured out the polyfelt to be. Then export. Let's see. The software that I did bulk of the work in is Fusion 360, which has a free license that's still plenty capable of doing this sort of work. Although with a full license, it's a very powerful tool, allowing for stress simulations and exporting in a number of other file types. I started by modeling the gallery wall and arranging the panels in the orientation, spacing, and elevation requested. I confirmed with the designer and curators that this is what they had envisioned and continued to design the mount. I had to simplify the models down because as scanned, they had well over 1 million points each scan, and that was far too much for Fusion 360 to handle. Using the reduced function, it went from a mesh of evenly spaced triangles to larger ones in the flats and smaller ones in areas that needed to retain detail. The goal was to work with models that had less than 10,000 points. Pretty big difference from the original. Once the model was simplified, I chose the points of contact that would register best and extruded blocks from the wall up through the mesh. To help with processing even more, I divided the mesh into only the areas that I needed to work with and converted those to solids. Using the combine function, I was able to cut the section of scan from the extruded block. After adding countersunk screw holes, I had a model for the wall side of the mount. And here's a template that I made that I'll talk about in a bit. Prior to doing the work in the previous slide, I had done a test of a 2-part printed mold that I would have cast in a epoxy paste. And here you can see one of those reduced sections and the front half of that mold. I tested to see that the padding fit properly, and it was a snug fit. I would have printed out molds in PVA filament, a water-soluble filament normally used for supports that can be removed with water and leave a better overhang surface. It was determined that this was a bulky design and a slimmer option must be available. Maybe carbon fiber. I set about making molds for the carbon fiber top shell. This is a minimal section of the merge, scan, and block brought together. As the molds were brought into the slicing software for the printer, they're auto-arranged to nest as well, have as few overhangs as possible. When arranging, pay attention to the flats and have those lined up with bed. Try to avoid overhangs. Pay attention to layer orientations for strength. And as with the overhangs, reduce the need for supports. The slicing software converts the mesh model from Fusion 360 into toolpaths called G-code that the printer can work with. The software automatically decides how best to extrude the thin line of hot plastic into walls, sparse infill, and supports if necessary. So here's a cutaway of one of those build plates. And here's a time lapse of what one of those prints ends up looking like. So this video is a print that took roughly 6 hours. But you can be working on other mounts while that's happening. Here's some of the molds in white. And then also these black blocks are printed in PETG. Clear seems to always test, test safely, and most of the colored filaments also have been testing okay. Also, this was going to have a barrier and not be enclosed, so I wasn't too worried about that. If I didn't mention, the black blocks are the wall-facing side. You can also see the brass threaded inserts for attaching the carbon fiber cells. Carbon fiber was chosen because it can conform to the natural shapes. It's lightweight and incredibly rigid in the direction of weave. With carbon twill, the strength will be left, right, up, down. Layers can be rotated to even out the directional strength. And unidirectional tape can be used if you need the strength more in one direction than others. West Systems 105 resin was used with the slow hardener, as it seems to be the best resin for longevity and off-gassing. If you're working with smaller amounts, rather than buying the quart size amounts, you can buy packs of 101 TS, which are patching packs of the same resin, but it's packed with a medium hardener, and I'm not certain on if it has different off-gassing properties. PVA mold release helps with demolding later on, and vacuum bagging helps press the fibers into the mold. The bagging comprises of a breather fabric, or a peel ply, a breather fabric, and the bagging sealed with the yellow bagging tape. There's also, over here, a special quick release vacuum fitting. Brushing the resin can often pull on those fibers, so stippling and pressing with popsicle sticks seems to be the best method. I'm far from being good at this, but got the job done. Here you can see the raw carbon fiber shells. Definitely room for improvement. You can kind of see there's some air bubbles and all that. Here you can see one of the test pieces that I did, still attached to the peel ply and breather fabric, separated from those, and with a mock-up test piece. An important note, wear your PPE. Carbon fiber dust will get on you and everything around you while trimming with the cutoff wheel. And if you've ever worked with fiberglass, this is so much worse. Here's the final mount before paint and padding. Later, the brass screws were replaced with black oxide security screws. As I was showing quite a few slides back, in Fusion I was able to make a template by making a cross-sectional sketch and laying out a 12 by 12 grid. I had our in-house graphic designer print out the template in 2 parts on our large format roll printer. The template was taped up and gave me precise locations of all the blocks. After placing the blocks, I removed them and the template and used the screw holes to put the blocks back up in the same place. After months of planning and prepping for this moment, the center panel was going to be joined with the completed mount for the first time. I had thought this through many times, but still had no way of knowing 100% for certain if it would fit correctly. The panel was lifted up and the 4 carbon shells were screwed into place. It hung tight to the wall, no gap between the felt and the wood. Onto the other 4 panels. At the start, I had made a rendering in Blender to show the team what it would look like with the texture and lighting. And the final result looked as good as I could hope. There was a part on the left panel that was noticed after installation to be a little bit loose, and I was asked if there's anything that I could do to secure it from curious hands. Having the model ready, I was able to quickly design and print out additional support. Our exhibit designer laid out the cases, elevations, and locations in Vectorworks. So here's a short walkthrough of the model on my phone and Blender rendering. Using computers will never replace our hammers, torches, benders, and welders, but hopefully in the right situations, it can be used alongside them as just another tool to help produce a better, safer, and maybe more invisible mount. Thank you.
So I have a quick question for you. We don't often talk about this part, but how much, like what percentage of time would you say it took just to research, like what kind of scanners, what kind of equipment, what kind of materials you were going to select?
I don't even know how to quantify that. The scanner that I used was actually my personal scanner that I've been using with some car design projects with a friend. The 3D printer, I had started out using a fairly inexpensive Ender 3 that I had at home, but for this project, I was able to convince the museum to buy a Bamboo Labs X1 carbon, and then general research. I have no clue.
Thank you, Allyn. There is a question. Would you be willing to include a materials list that could be posted on the IMF website or added to your presentation when we post it on our YouTube channel?
I can definitely try that, and I do have with me, so anyone that's in person, I have the prototype mount and a few of the carbon fiber materials.
Thank you. There's another question. What is the approximate weight of each of the panels?
I unfortunately don't have a specific weight. I don't imagine that the middle panel is more than 30 or 40 pounds.
Thank you.
I just have that was a really interesting process. And I appreciated the fact that you said that you could make other mounts while it was being printed and all of that. Now that you've finished it, would you do it that way again? I'm always curious because my company doesn't work with 3D printers. We don't have the resources, but I'm always curious from a timing perspective. like the cost of doing the 3D printing and all of those steps versus sort of a more traditional hand maker way of doing it, would you do that again the same way from a timing perspective? And how long did it take you to do it from start to finish? Sorry, thanks.
Just starting with what you were just asking about timing. It's hard to judge how doing it again would go for timing, since so much of it was figuring out what the process was. Would I do it again the same way? I'm sure, as with any mount, you'd make tweaks, but I definitely think it's headed in the right direction. You were saying that you don't have the resources, and I've thought about that, and I don't see it being much more out of reach than many other tools, especially when buying specialty pliers are potentially $100 for a single plier, and so the 3D printers can be quite affordable. I think the filament altogether throughout, so the consumable all throughout the process, couldn't have been more than $50 a filament for the entire mount. So I think it is rather attainable.
That was a really impressive process, especially since you were doing all the problem solving as you went. It was really good job. I was wondering, can you paint carbon fiber? I don't know really anything about making it.
Yeah, I especially with the process that I went through, where the visible side was the peel ply side of the carbon. It has a lot of texture for paint to grab onto. And I was just painting those shells with Benjamin Moore low VOC latex paint.
Okay. I didn't know if you considered in painting or anything like that, or that would have been a lot of in painting, though.
Yeah, and I think the philosophy at our museum is that we don't in paint. So.
Okay, thanks.
Thank you, Allyn.
Thank you.